Dear students, welcome to Mass Academy. In this video, we are discussing Grade 10 Advanced Physics Exam Paper, Term 2 for the year 2022. The figure below shows 2 point equal charges Y and Z. What will happen if a negative test charge was placed at point X? So if you keep a negative test charge here, a negative charge, if you keep at this point, what will happen to that charge? So here you can see the field lines are directed inward, so this charge will be a negative charge. So this is a negative charge, and here you can see the field lines are directed outward, so this is a positive charge. This Y and Z are equal positive and negative charges, means the magnitude of the charge is same. Y is positive and Z is negative. So here if you keep a negative charge here, you can see this negative charge will experience force from this charge Z, and the negative charge will experience a force from this charge Y. So this is negative charge, so the force on minus Q charge, force on the charge at X by Z, that will be repulsive force along this direction, and the force acting on this charge Q by this charge Y, because the charge Y is a positive charge, so the force will be directed to this side. So this negative force, that is force applied by the charge Z, will be greater than the force applied by charge Y. The reason is charge Z is near to this point X. So what happens to this negative charge? This negative charge will move along this direction. So we can say this negative charge move to the right side. It will move towards right. That is the answer to this question. Question number 2. Which of the following statement is true about electric charge? It does not have mass. That is not correct, because electric charge has mass. It could be destroyed by heat. Not correct, because electric charge can never be created nor be destroyed. Electric charge can be transferred from one object to the other. It cannot be destroyed. It can transfer between the objects. That is correct. Question number 3. A kettle has a power of 120 watts, is connected to a 12-volt electric line. What is the current in the circuit? So here we have the equation to calculate power. Power is equal to VI, potential difference, multiplied current. In this we need to calculate current. So current, that is equal to, when I rewrite this equation, power divided by V. The value of power is 120 watts divided by the value of potential difference, V is 12. So the answer will be 10, and the unit of current is ampere. 10 ampere is our answer to this question. Question number 4 from Doppler effect. A horn of a car attracts attention of a stationary buoy. If the car is approaching the buoy at 70 km per hour and the horn has a frequency of 560 Hz, what is the frequency of the sound perceived by the buoy? So the detected frequency FD is given by this equation, source frequency into V. Here V is the speed of sound and VD speed of the detector. So here The detector is the buoy, so speed of the buoy, and v is again speed of sound, and vs is the speed of the source. So what is given in the question? If the car is approaching the buoy at 70 km/h, so here the speed of the source is given because the horn is produced by the car. So car is the source of sound waves. Speed of the car is 70 km/h, but we need the speed in meter per second. So to change the speed to meter per second, we will divide this speed by 3.6. When you divide a speed given in km/h by 3.6, you will get the speed in meter per second. Now I am using my calculator to calculate this value of speed in meter per second. 70 divided by 3.6 equals 19.4. So the speed of the car is 19.4 meter per second. So here the car is moving from the car is moving to the buoy, towards the buoy. So the direction is source to the detector. The direction from source to the detector is positive, taken as positive. So the direction, if the source is moving towards the detector, it is taken as positive. And the next is given here. The horn has a frequency. The frequency of the source is given. The frequency of the sound, that is 560 Hz, the original frequency. And what is the frequency of sound perceived by the buoy? You need to calculate the frequency of the sound received by the detector. And the speed of the sound v is given here, that is 343 meter per second. So we will use this equation to solve. So fd, the frequency of sound received by the detector, that is fs multiplied, here fs is 560, multiplied v minus 343 minus vd, that is the detector speed. Here you can see if the car is approaching the buoy and the buoy is not moving, right? So the speed of the detector is 0 divided by, again v, the speed of sound is 343 minus speed of the source, that is 19.4, equals 560 multiplied 343 divided by 343 minus 19.4, 393. The frequency of the received sound by the buoy is 593. When you do the calculation, you will get 593 hertz. Yes, 593.57. That is the calculated value. $594, okay, because 593.57. So this is our answer to the question. Question number 5 is from Ohm's law. What is the reading of the ammeter circuit? Ammeter measures the current in the circuit. So what is the equation to calculate current? From the Ohm's law, we have current is equal to V by R, that is potential difference divided by resistance. So 27 divided by the value of resistance is 9. 27 divided by 9 is 3, right? 3 ampere. Question number 6. What is the magnitude of electric field from 30 centimeter from a point charge Q is equal to 30 nanocoulomb? So here in this question, charge is given. Charge is equal to 30 nanocoulomb. So 30 nano means 10 to the power negative 9. So this is how we write nanocoulomb. And the distance from the charge R is equal to 30 centimeter. Centimeter is not the SI unit of distance. We need to convert centimeter to meter by dividing by 100. So 30 divided by 100, that is equal to 0.3 meters. So what is the equation to calculate electric field at a point? So here we have a charge and the value of charge is 30 nanocoulomb. So what will be the electric field at a point that is 30 centimeter away from the charge? So I will write point P. The equation to calculate this electric field at a point P at a distance R from the given charge is K multiplied the charge Q divided by distance squared. So the value of K is a constant 10 to the power 9 into 10 to the power 9 multiplied Q, the value of charge 30 multiplied 10 to the power negative 9 divided by square of the distance. Distance is 0.3, so 0.3 squared equals 9 multiplied 10 to the power 9 multiplied 30 multiplied 10 to the power negative 9 over 0.3 squared. The answer is 3000. So the value of electric field is 3000 and the unit of electric field is Newton per coulomb. Newton per coulomb. So here answer is given in standard form. Question number 7. An electric field due to positively charged spherical conductor is shown below, at which point the electric field is weakest. So that depends on the distance. So for example, if point C, that is not given, not shown here, you cannot see in the diagram. For example, point C is here. So the weakest means the weakest electric field will be at the far distance. So if the distance is greater, the strength of electric field will be less. So we will mark the point C. If the pitch of sound increases, how its frequency and wavelength change? See, if pitch means frequency, so if pitch increases, which means frequency increases, and frequency and wavelength are inversely proportional. When frequency increases, the wavelength will decrease. So how do we understand these things? We have a speed of light or speed of sound. V is equal to f lambda, right? If speed is constant, so when frequency increases, the wavelength will decrease. So that speed will be constant. Question number 9 from electric field. What does electric field strength depend on? Electric field strength, the equation for electric field strength by a charge E is K multiplied K is a constant, Q divided by R square. So electric field strength depend on two factors, the Q and R. What is Q? Q is charge And what is r? R is the distance from the charge. Question number 10. Which of the following would have the greatest resistance? We know that the resistance of a conductor increases when its length increases, and the resistance decreases when its diameter increases. So you need to check which one has the largest length and the smallest diameter, which will have the greatest resistance. So here the aluminium wire, its resistance is 10 centimeter and diameter is 3 centimeter. So here you can see the length is less, so resistance will be less, same diameter. Here length is same, but the problem is diameter is greater, so the resistance will be less. So the resistance will be greater if the length is greater and the diameter is less. So the answer to this question is the first one, because in this the wire has the greater length and the smaller diameter compared to other choices given in the question. Question number 11, from the speed of sound. You want to measure the speed of sound in 3 different materials: glass, water, and air. What is the correct order of speed of sound in these different materials? So speed of sound depends on the density of the material. If the density is greater, the speed will be greater. So the sound will have greater speed or greater speed in glass, then water, then air. The speed of sound is greatest in glass, then water, and then air, because speed of sound depends on the density of the material. Greater density, greater speed. Question number 12 is from conductor and insulator. How does an electric conductor differ from an insulator? See, in an electric conductor, electrons will be free, or there will be very large number of free electrons. So these electrons can move within the conductor. And insulator, the number of free electrons will be very, very less. So electric charges can move easily in a conductor compared to insulator. So what is electric charge? Electric charge is electron, right? Electron in the conductor. So in conductors, these electrons are free to move, so they can move easily. But in insulator, the free electrons, that is the electric charges, are not, for them it's not easy to move. Loudness of sound is the intensity of sound as perceived by the ear and interpreted by the brain. What does loudness depend on? Loudness depends on the amplitude of the wave. So here you have 2 qualities of the sound wave. One is pitch. Pitch depends on the frequency of the wave, and another is loudness. Loudness depends on the amplitude of the wave. Question number 14, from properties of sound. What is the unit of measuring loudness of a sound wave? So the name of the unit is decibel. Next question is from the wave speed. A fire whistle emits a tone of 170 Hz. Take the speed of sound is 340 meter per second. What is the wavelength? So here you have this equation. In this equation, lambda represent wavelength. So what is wavelength? Wavelength is the speed over frequency. So what is the speed of the wave in this question? Speed of the wave is given 340 over frequency. Frequency is 170. When you do the calculation, you will get 2, and unit of wavelength is meters. So 2 meter is the answer. Next question is from electric field. What is the unit of electric field? Unit of electric field is Newton per coulomb. So why this is the unit of electric field? Because we have the equation for electric field. Electric field strength at a point is given by force divided by charge. The unit of force is Newton and the unit of charge is coulomb. So Newton per coulomb is the unit of electric field strength. Question number 17, that's also from electric charge. What is the method of charging? So here you can see this conductor or charged object is touching this metal sphere. So there is a contact. So the name of the method of charging is charging by conduction. Next question is from sound wave. Why is sound wave classified as longitudinal wave? In longitudinal wave, what happens is the particle vibrate parallel to the direction of motion. If the wave is moving along this direction, so particle vibrate like this to and fro. So in longitudinal wave, the vibration is to and fro, forward and backward, we can say like that. Then in a transverse wave, if it is a transverse wave and this is the direction of travel of the wave, so particle in the medium will vibrate like up and down, up and down, up and down. So if the particle vibrate to and fro, or we say parallel, because the motion of the particle is it's like to and fro, okay, it's parallel or along the direction of travel of the wave. Question number 19. 3 charged spheres are at positions shown in the figure. What is the net force on sphere B? So here on sphere B, there will be two forces acting, because here the charge at A or the charge A will apply a force on charge B. Charge A is a negative charge, so this force will be an attractive force. So the direction of that force will be towards A. And this charge B will experience a second force, that is from charge C. Charge C is a positive charge. So this charge C will apply a repulsive force on B. So the force applied by charge C will be along this direction. So here this one we will mark FC, force applied by charge C, and this is FA, force applied by charge A. Now we will calculate both the forces, and the net force will be the total of the two forces. To calculate the net force, we need to add. Why? Because both the forces are acting in the same direction. So the direction will be to the left side, right? Towards left side, the direction of the net force. So what is the force applied by charge A on charge B? So I will just write FAB. That is equal to the equation to calculate electrostatic force between two charges is given by Coulomb's law. K multiplied Q1 multiplied Q2 over R squared. So here the value of K is always 9 into 10 to the power 9 multiplied Q1, that is 8.5 multiplied 10 to the power negative 6, and Q2, that is charge at B, 3.1 multiplied 10 to the power negative 6, divided by the square of the distance. Distance is 0.4 meter, so 0.4 squared. Now we will use our calculator to do this calculation and to get the answer. The force between the force applied by charge A on charge B. 9 multiplied 10 to the power 9 multiplied 8.5 times 10 to the power negative 6 times 3.1 times 10 to the power negative 6 over 0.4 squared equals 1.48 Newton. So this I am getting 1.48 Newton. So here I didn't use a negative sign here. No problem. Negative sign just tells that the force is attractive and the direction will be towards the charge A. Then next, the second force experienced by the charge B, that is applied by charge C, that is Fc, the force applied by C on B equals K multiplied Q1 multiplied Q2 over R squared equals, value of K is always same, 9 into 10 to the power 9 plus the charge at C, that is 6.4 multiplied 10 to the power negative 6 multiplied charge at B, that is 3.1 multiplied 10 to the power negative 6 divided by the distance between C and B, that is 0.2 squared. Nine times 10 to the power 9 multiplied 6.4 times 10 to the power negative 6 times 3.1 times 10 to the power negative 6 over 0.2 squared equals 4.46. So the total force will be 1.48 plus 4.46 net force, right? Net force. We are adding because both the forces are acting in the same direction. 1.48 plus 4.46 equals 5.94 Newton towards left. So the answer is 6 Newton to the left. According to figure below, what point is the sound source heading towards? So you can see here the sound source is heading towards B. Why? Because here the wavefronts are closer together, means frequency is increasing. So you can see if the wavefronts are closer in that direction, the sound source is moving. So here answer is towards B. Question number 21. The figure below shows two charged bodies A and B according to law of conservation of charge. What happened after the contact between A and B? When A and B come in contact, the charge will be equally distributed. So this charge will be 75 electronic charge. Here also 75 electronic charge, right? 150 divided by 2. After contact, the charge will be like this, 75 and 75. Two charges are repelled by a force of 2 Newton. If the distance between them doubled, what is the force between the charges? See here, initially the force is equal to 2 Newton, and if the distance is doubled, so we know that the force is directly proportional to or inversely proportional to the square of the distance, right? As force is inversely proportional to square of the distance, which means when distance increases, force decreases. As it is inversely proportional to square of the distance, what happens is when distance multiplied by 2, then force will be divided by 4, because the square of 2 is 4, right? So 2 squared is 4. When distance multiplied by 3 times, means when distance increased by 3 times, then what is the square of 3? 9, right? So force will decrease. When distance increase, force will decrease according to the square of the distance. So 3 square is 9. When distance changes to 4r, means when distance increases by 4 times, then force divided by square of 4. Square of 4 is 16, right? 4 squared is 16. So here the force is 2 Newton when distance is increased to 2 times. When r changes to 2r, what happens to force? This 2 Newton force will decrease to 2 divided by 2 squared. 2 squared is 4, right? So 2 Newton divided by 4, 2 by 4 is 0.5 Newton. So 0.5 Newton is our answer to this question. Question number 23. Two electric charges plus Q and minus Q are separated by a distance. A third charge minus Q is placed at point P. So here a charge minus Q is placed. What will be the direction of the net force? So here you can see when there is a charge kept here at P, there will be, this is a negative charge, so this negative charge will apply a repulsive force on this negative charge here at P. So that direction of that force will be along this direction, and this positive charge will apply a force that will be its negative, right, attractive force. So that force will be along this direction. So when we resolve these two forces, what happens is the horizontal component of this force and this force will be cancelled, and the vertical component will be added. So the net force will be in the downward direction. Okay, so this will be the direction of the net force acting on the charge P. Question number 24. The figure shows two equal charges Q1 and Q2 0.01 meter apart exerts a force of magnitude 9.2 times 10 to the power negative 24 Newton on each other. What's the value of either charge? So we have the equation of Coulomb's law, that is force is equal to K multiplied Q1 multiplied Q2 over R squared. So force is given here. The value of the force is 9.2 times 10 to the power negative 24, which equals the value of K is 9 into 10 to the power 9. And here it is given, the figure shows Q1 and Q2, they are equal charges. As they are equal charges, instead of writing Q1 and Q2, I can write Q and Q because they are equal. So Q and Q will be Q squared divided by the Distance squared, distance is 0.01 meter, so 0.01 squared. We need to calculate this q, so I will just rewrite this equation. Q squared is equal to 9.2 times 10 to the power negative 24 multiplied 0.01 squared over 9 times 10 to the power 9. As we need to calculate the charge q, we will take the square root of all these. 9.2 times 10 to the power negative 24 multiplied 0.01 squared over 9 times 10 to the power 9, which equals square root of 9.2 times 10 to the power negative 24 times 0.01 squared over 9 times 10 to the power 9 equals 3.2 times 10 to the power negative 19. 3.2 times 10 to the power negative 19 coulomb. So 3.2 times 10 to the power negative 19 coulomb is the magnitude of the charge. And here you can see in the diagram, Q1 will be positive because here electric field lines are directed outwards, and Q2 will be negative because electric field lines are directed inward. Question number 25. Which of the following diagram best illustrates an electroscope when positively charged sphere come close to the knob? When positively charged sphere come close to the knob, yes, the positive charges are repelled. So positive charge will repel from here and electrons will be attracted. So there will be more negative charges this side and positive charges will be accumulated at the bottom. So this is our answer to the question. Thank you all the students for watching this video.